Good afternoon, class. We are looking at practice test number 4 for statistics. This is module 4, covering chapters 8 and 9. Chapter 8, hypothesis testing, and chapter 9, inferences from two samples. And this is chapter 8, hypothesis testing. So let's look at some basics of hypothesis testing. A test of hypothesis is always about a population parameter. We are always interested in information about the population, not a sample. Population parameter is called. The observed value of a test statistic is the value that we calculate, that is calculated for a sample statistic. Meaning we have a formula and we calculate this. As the sample size gets larger, both type 1 and type 2 errors decrease or increase. They decrease. Define type 1 error, rejecting a null hypothesis when it's true, known as also false positive. What about type 2 error? Failing to reject a null hypothesis when it's false, known as false negative. The value of alpha is called the probability of a type 1 error. The value for the probability of type 1 error. The value of beta is called the probability of type 2 error. The value of 1 minus beta is called the power of the test. Correct decision, probability of rejecting a false hypothesis. Could somebody read this question, please?
In 1990, 5.8% of job applicants who were tested for drugs failed the test. At the 0.01 significance level, testers claimed that the failure rate is now lower if a simple random sample of 1,520 current job applicants results in 58 failures. Does the result suggest that fewer job applicants now use drugs? Should I read A, B, C, D, E, F?
Sure, please.
Okay. A, state the null and alternative hypothesis. B, calculate the value of test statistic. C, find a critical value. D, make a decision. E, find a p-value and make a decision. Is this decision in agreement with the previous one? F, what is type 1 error? What is the probability of making type 1 error?
Perfect. What I want to show you a general idea as to how we do the test of hypothesis. Number one, let's read the given, which is understanding it symbolically. 5.8%, we are dealing with the binomial distribution. P is 0.058 or 5.8%. That's a proportion. Either they fail the drug test or they don't. Alpha is 0.01. Significance level of the test is called alpha. We are going to check the claim in a moment, but for now, sample of 1520, that means N is 1520. Out of those 1520, there were 58 failures. X is 58. So number one, what is given? So a couple of things we want to add. So binomial distribution, there are two outcomes. That's the reason. So if P is 0.058, Q must be 1 minus that, which makes it 0.942. And recall, we approximate the binomial distribution by normal distribution as long as NP and NQ are large. So if you multiply n by p and n by q must be large, and they are both larger than or equal to 10. In fact, you can multiply the p by 1520. You see this is larger than 10. Clearly, this becomes larger. I'll leave it for you to verify that. Therefore, we can use ND, normal distribution. And one calculation that is crucial here is calculating p hat, which is x over n, 58 over 1520. And you can simplify the fraction, or if you're using decimals, you want to make sure you keep enough decimals. Now, what I want to mention is what's going on here. So even if they don't ask you here, does the results suggest that fewer job applicants now use the drug? That means do the test of hypothesis. So here's the way I do the test of hypothesis. Step 1, I write H1, H0 and H1, also known as HA. This is the alternative hypothesis. Sometimes they call it H1 or HA for alternative. And I write the claim. It either belongs to H0 or H1, and the tails would be left tail, right tail, or two-tail test. So that's the first step that they're asking. Then test statistic. This you calculate as the second step, and that requires a formula that is given to you in a formula sheet. The third part, finding the critical value. This is the traditional method, by the way. When we find the critical value, is called it's a traditional method of doing the test of hypothesis. So critical value comes from the choice of alpha. And then you make a decision. When you make a decision, there are three things you mentioned. Number one, your decision, or part A of that, is you reject or not reject, fail to reject H0, because the decision is always about H0. Then you write the claim. If the claim depends on H0 and H1, you write it whether it's true or false. And then you restate the decision by writing there is or there is not sufficient evidence to support the claim. So make a decision that has three parts. I will show you. In many cases, they use the p-value, especially when it comes to technology. So instead of part C using the traditional method, they use the p-value. And I will show you what that is. And finally, in this question, they're asking for type 1 and type 2. But if the question stops here, you just follow those 4 steps. And I want to show you those 4 steps. So in this case, because we are dealing with the proportion z equals p hat minus p over the square root of pq over n, let me clean up the mess so you can see that. So this is the value of test statistic, and you can find it in your formula sheet for this question. So from the previous page, we're going to write p, q, this is 0.058. Q is 1 minus that, alpha is 0.01. And p hat, we calculated it to be 58 over 1520 or 0.03816. So this is from the previous page. Now, the very first step is H0. H0, P equals 0.058. When you write H0 and H1, you have to use population parameter. So you use P, you never use P hat, okay? Now, you always use equality for H0, and you use the inequality for H1. Sometimes they may write greater than or equal here, but equality goes with H0. In this case, why P less than 0.08? Because it says test the claim that the failure rate is now lower. So take a look at this, lower. That means less than 0.058. And that is the claim. So I'm going to put claim next to that. And because it's less than, it's considered left-tailed test. LTT short for left-tailed test. The second step is calculating TS, test statistic, using this formula. So let's plug in. So P hat, which we have calculated it, minus P over the square root of P times Q over N. That's a formula. You do the math, you end up with negative 3.309. According to the traditional method, this uses the traditional method. Critical value comes from the choice of alpha. Alpha is 0.01. That means the area to the left is 0.01 according to this, because it's a left tail test. And remember, this is a binomial distribution approximated by normal distribution, and we're going to go to the z. And from the z, we find out that this critical value is negative 2.33, or a little bit more exact is negative 2.325. So how do we make a decision? You should always draw. So take a look at the general case. So you have alpha of 0.01 with the z being negative 2.325, so somewhere here. And if you draw that, then compared to that, what happens to this one? Is this in this area or in the tail? So take a look. This is negative 2.33 or negative 2.325. This is the critical value. Your test statistics. So this is the rejection region. Because it's left tail test, if we continue with this line, this is called rejection region. And this is called NRR, non-rejection region. So this number, test statistic, where does it end? Here or here? Negative 3.309 is less than this number, so it ends up somewhere here. And therefore, it's in the rejection region. So the very first part for making a decision is, what do you do here? You just make a decision about H0. You are going to reject H0. I want you to look at the first part only for now. Reject H0 because the value of the test statistic is inside the rejection region. So this is RR, rejection region, RR. So let's go back here. If you're rejecting H0, loosely you accept H1. That means you accept whatever comes with H1, which is the claim. So you're accepting the claim. That means the claim is true. Okay, just so reject the H0. If the claim was next to H0, you would reject the claim also, becomes false, but it's not, therefore it becomes true. Now you're going to write, there is sufficient evidence to support the claim that the failure rate among job applicants for drugs is now lower. Results suggest that fewer job applicants now use drugs. Basically, you use the same sentence from here and reword it with there is sufficient evidence or there is not sufficient evidence. There are different ways of writing it, so you want to be careful with that. Now, we can do the same thing using the p-value. So again, in this case, for this step, instead of the critical value and finding this, we can find the p-value. So the question is, what is the p-value? We start from here. What type of a test? We have a left tail test or we have a right tail test. If it's a left tail test, the area to the left of the test statistic is the p-value. If it's a right tail test, the area to the right of the test statistic. And as you recall, for example, in our case, it's a left tail test because test statistic is negative 3.309. Sometimes it may be two tail test when we don't have the equality. So we don't have less than or greater than, we have not equal. So the sign for left tail test less than, for right tail test greater than, and for this case not equal, which goes with H1, okay? Not equal, it's a two-tail test. So when you calculate the test statistic, if it's negative, area to the left of that times 2. If it's positive, area to the right times 2. So twice the area to the right of the test statistic or twice the area to the left of the test statistic. And here's how you make a decision. If the p-value is less than alpha or less than or equal to alpha, you reject the null hypothesis. And if it's greater than alpha, you don't. You fail to reject the null hypothesis. Some may use accept, but a more proper wording is fail to reject. So for this question, again, this was 0.058. We remember it was a left tail test. Z was negative 3.309. So the p-value would be the area to the left of test statistic. So this is our test statistic. So this area. Now you use technology or tables and you come up with the answer. So if you use the table, it gives you roughly 0.0005. You compare this number to alpha. It's either less than that or greater than that. This number is less than the choice of alpha, so reject. P-value, which is this one, is less than or equal to alpha 0.01. Therefore, we have the same decision, reject the null hypothesis. Reject the null hypothesis. Now, if you were to do this with technology, we are going to do one proportion Z test, and we put the information in as follows. Take a look. So we are going to put 0.058 as a P. X is 58. N is 1520. And over here, we go with one of those, not equal to, less than, greater than. So you check mark less than because it was a left tail test. And then you calculate. It gives you this. And take a look at what it gives you. Number one, I want you to look at this Z. This is the value of test statistic. Test statistic, which of course has a lot more decimals. Here's the p-value. I want you to see what the p-value is, and I'm going to write that. This means 4.673. Let me just write that. So I want to make sure you are comfortable with the concept. This means 4.67, let's say 3 times 10 to the power of minus 4. That's what E is for. And if you change this to a decimal, you have to move this 4 places, and it becomes this number. As you can see, it's very close to this. This is how you read the p-value. Take a look at the p-hat is also calculated for us. The p-hat is also calculated. So if you put it into a calculator, it does a lot of calculation for us. So you need to use one proportion z-test and put the information for p, x, n. What is type 1 error? What is the probability of making type 1 error? So refreshing everyone's memory, type 1 error by definition is rejecting H0 when H0 is true. Therefore, for this question, rejecting the claim that the failure rate of job applicants who were tested for drugs is 5.8% when the percentage is actually 5.8%. And probability of type 1 error is equal to the choice of alpha, and the choice of alpha has a value of 0.01. So it depends on what the question is asking us. Could somebody read this, please?
A sample of 54 bears has a mean weight of 182.9 pounds. Let's assume that the standard deviation of weights of all such bears is known to be 121.8 pounds at alpha 0.1. Is there enough evidence to support the claim that the population mean of all such bear weights is less than 200 pounds?
Perfect. Again, you're dealing with a word problem. Let's write the given. The very first number is n is 54. The very second number, mean weight, x bar. Why is this x bar? Because those 54 bears have a mean weight of 182.9. Not all bears, only those 54. Sigma is 121.8. Why is it sigma? Let's assume the standard deviation of weights of all, that's the key word, all such bears is 121.8. Alpha, or significance level, 0.1. Now, when you're checking this, is there enough evidence to support the claim that the population mean of all such bear weights is less than 200 pounds? That means you're assuming mu is 200 pounds. And we are going to go with those 4 steps. Step number 1, you got to write H0. And you're going to write mu equals 200. Again, you will always use population parameters. If you ever use an X bar here, you're wrong. We are not checking a sample, we are checking population. So mu is what? 200. What are we testing? Test the claim that it's less than 200 pounds. Mu is less than 200. What does it make it? Left tail test, and that's a claim. The next thing is to calculate the test statistic. So what is the test statistic? V equals x bar minus mu over sigma over square root of n. Sigma is known, we use the z. So plug in. That's why you write the given. So when you want to plug in here, you have absolutely no problem. X bar is 182.9. minus mu is 200 over sigma is 121.8 over the square root of n, which is 54. You do the math and you end up with negative 1.0317. Now we do the CV. Critical value comes from the choice of alpha. The choice of alpha in this question is 0.1. And this is a left tail test. That means when you draw, you put everything, the tail, the total area in the tail is 0.1. And that gives you the Z value. So understand, you have a drawing like this Z-score, which represents the critical value here is negative 1.285. So alpha is 0.1, Z is negative 1.285. Now, here's your test statistic. This is the rejection region. The tail is the rejection region, and this is a non-rejection region. This number either ends up here and you reject H0, or it ends up here, you do not reject H0. So where does this end? This number is larger than this number, and it ends somewhere here. It doesn't have to be perfect, but definitely it's in the non-rejection region. Non-rejection region, therefore, don't reject. Fail to reject H0. If you don't reject H0, that means you don't reject anything that comes with it. On the other hand, you are going to reject H1, and that means you reject everything that comes with it. That means the claim is rejected. That means the claim becomes false. Here's how you write it. Fail to reject the null hypothesis because the value of test statistic is inside the non-rejection region, non-rejection region. So that's the first part. What does it do to your claim? The claim becomes false because if you're not rejecting H0, you are rejecting H1 in a sense, and you're rejecting the claim becomes false. How do you write it? Now, instead of writing there is, you're going to write there is not sufficient evidence to support the claim that the population mean of all bear weights is less than 200 pounds. You basically write the same sentence here, and you just write there is or there is not according to what your decision was in the first place. What if we want to do it with a calculator? We're going to use the Z-test, and you go to stat test, Z-test, and you put in the information. So if we go to Z-test, it's going to ask us for mu. Again, the given will save us 200. It will ask us for sigma. It will ask us for X bar. It will ask us for N. And one of those, again, you have to choose not equal, less than, or greater than. And that's why you write this, it's less than. And then you do the calculation. Now notice what it gives us. I want to make sure we understand. Number one, this number is your, which says Z is your test statistic. This is your test statistic. This P is the p-value. So the p-value is 0.1511. It continues indefinitely, but 0.151. Compare this number with the choice of alpha. It's either larger or smaller. This one is larger. So this is your p-value. We put it here. Larger than alpha. So we have the same decision. Remember, when it's larger than alpha, fail to reject the null hypothesis. Same decision. Could somebody read this question, please?
"16 new textbooks in the college bookstore had prices with the mean of $70.41, with a standard deviation of $19.70. Use a 0.05 significance level to test the claim that the mean price of a textbook at this college is less than $75. Assume normal population."
Perfect. Again, we are dealing with a word problem. That means let's write the given. The very first number is 16. That's N. The mean Those 16 have a mean of 70.41. And those 16 have a standard deviation of 19.7. So this is X bar, this is S. Here's your significance level of alpha. And we are testing the claim that the mean price is less than this. That means this is the population mean mu. So N is 16. The reason this is X bar and this is S, because these two values go back to those 16, not all. Alpha is 0.05, mu is 75. Spend enough time to understand this part and everything will fall into place. So basically, we are going to write the first step as the previous one. We are just changing the number. H0 mu is 75, H1 mu is less than 75. This is still a left tail test, and that's the claim. The next one is calculating the test statistic, and now we use T because sigma is missing. And T is similar to Z. X bar minus mu is identical to what we had before, but the denominator instead of sigma is S over square root of N. Z was the same thing, X bar minus mu over sigma over square root of N. Now it's S. So plug in. That's why now when you have this formula, just plug in and do the evaluation. So 70.41 minus 75 over 19.7 over the square root of 16. And when you do the math, you end up with negative 0.9320. Now we're going to use the critical value. And critical value comes from the choice of alpha, which is 0.05, and degrees of freedom, which is n minus 1 or 15. So degrees of freedom is n minus 1, which makes it 15. And so from here, if you recall the t-table on the left side, left column, you go down until you hit the number 15. We are looking for number 15. And then up here, you have area in one tail, area in two tails, okay? So you look for the area of 0.05, but since it's left tail test, that's the area 0.05 in one tail. So this is what you're looking for, which gives you the same answer as area in two tails being 0.1. So you're looking for this one, and this is the answer. Because it's left tail test, you write negative 1.753. So you got to pay attention to all of that. Now, graphing makes it easy to come up with the decision. So if you look at the graph, at alpha of 0.01, the critical value of negative 1.753, where does this end? Is this ending in the tail, which is the rejection region, or not the tail, which is a non-rejection region? So again, let me write this. This is the rejection region, this side, and this is non-rejection region. And since this number is larger than this number, we are somewhere here. Again, it doesn't have to be to scale, but definitely this lands in a non-rejection region. So you don't reject H0. That means you fail to reject H0. If you don't reject H0, you're going to reject H1, and therefore you reject the claim. The claim becomes false, and there is not sufficient evidence to support that. So fail to reject the null hypothesis because the value of the test statistic is inside the non-rejection region. That's why. If you don't reject H0, you reject H1, claim becomes false, and there is not sufficient evidence to support the claim that the mean price of a textbook at this college is less than $75. If you were to do this by technology, again, you have to write the given, okay? We are going to do the mean t-test. So this is the t-test, and you decide to put the data. If the data is given for 16 pieces, or the stats, in this case, stats is given mu is 75, X bar is 70.41, S is 19.7, N is 16, and again, you choose one of those three, less than. And you calculate, it gives you this, and I want to show you what that means. Look at this value is your test statistic. We've already calculated it. This is your p-value of 0.183. And that compared to alpha of 0.05, that's larger. So p-value is larger than alpha of 0.05. That means fail to reject the null hypothesis, which is the same decision. Fail to reject the null hypothesis. I hope you see the methodology. All of them repeat. Step 1, step 2, step 3, step 4. And in the case of a step 3, you may use the p-value in some instances and the technology, but remember the formula, and the formula sheet does have that. Could somebody read this question, please?
Tests in the author's past statistics classes have scores with the standard deviation equal to 14.1. One of his current classes now has 27 test scores with the standard deviation of 9.3. Use a 0.01 significance level to test the claim that this current class has less variation than past classes. Does a lower standard deviation suggest that the current class is doing better? Assume the population is normal.
Excellent. So again, what is given? Obviously, we have ND or normal distribution. This is sigma or S test in the author's past statistic class have a score of with a standard deviation 14.1. It doesn't pertain to any specific sample size, so this makes it sigma. The current one, N is 27. The current one has N equal 27, S equals 9.3, and alpha is 0.01. So we have standard deviation for the population, standard deviation for the sample, and that's why you have to write them symbolically. So you need to understand the difference between a sigma and S. Now, the first step, H0 sigma is 14.1. We are testing the claim that this current class has less variation. Sigma is less than 14.1. And this is the claim. And again, this is a left-tailed test. One thing I want to make a point of, in some instances, they may use sigma squared because it says variation instead of the standard deviation. If they use sigma squared, you want to pay attention to the notation. You must raise this to the power of 2. Same thing here. So they may use sigma squared which is 14.1 to the power of 2. And you want to be very careful when you do your homework or your exam question. So 14.1 squared if they use sigma squared. The next step is the test statistic. Chi-squared is n minus 1 s squared over sigma squared. Whether they use sigma or sigma squared, the test statistic has this formula. And again, this formula is available in the formula sheet. 27 minus 1 s 9.3 squared over sigma 14.1 squared. And that gives us 11.311. Now, the next step is the critical value with the choice of alpha and degrees of freedom of n minus 1. N 27 minus 1 gives us 26. Now, this uses chi-square distribution. And chi-square distribution, we need the area to the right, and we need the degrees of the freedom. And in this case, alpha is 0.01. That means area to the left is 0.01. Why area to the left? Because it's a left-hand test. What is the area to the right? 0.99. So if you look at a portion of the table, chi-square table, remember, chi-square table is skewed to the right, and you need the area to the right. In this case, we are looking in the left column, we go down until you hit number 26. So that's number 26, 27 minus 1. And then at top here, you look for 1 minus 0.01 or 0.99. Area to the right is 0.99. And you find the answer and you put it there. So chi-squared is chi-squared of 1 minus alpha, or chi-squared of 0.99, which is 12.198. Let's do the drawing. Here's your critical value, and here's the rejection region, here's the non-rejection region. So your test statistic, and remember it starts from 0 and goes to infinity. Your test statistic is less than the critical value. That puts us way into the rejection region. So we are going to reject the null hypothesis. If you're rejecting the null hypothesis, you're loosely put, you're accepting H1, the claim becomes true. So reject the null hypothesis because the value of test statistic is inside the rejection region. The claim is true, then there is sufficient evidence to support the claim that this current class has less variation than past classes. However, a lower standard deviation doesn't suggest that the current class is doing better. It just means that the grade is more homogeneous, okay? Homogeneous, closer to the mean. Mean value might be different. That indicates whether they are doing better or not. When the smaller the standard deviation, the closer the values are together. And that's ideal, for example, for a company when they are making or building something. So what this means is that the grade is more homogeneous and the values are closer, the values for those grades. Here's another way of doing that. If we find the area for chi-squared as follows, chi-squared area. So you go to chi-squared CDF by using second variables. The lower is 0, okay, because it goes from 0 to infinity, and the upper is 11.311. I'm looking at the concept of a p-value. In this case, because it's left tail test, the area to the left of 11.311. Degrees of freedom of 26, and it results in the following. So what is this? This is the area to the left of test statistic 11.311, which is the definition of a p-value. So the p-value is 0.005. If we stop here, 5.6, and that's compared to alpha, it's smaller. So reject the null hypothesis. So this is your p-value, everybody. 0.005. If you want to stop here, makes it 6. Okay, pay attention to your rounding accordingly. And that's clearly less than alpha of 0.01. And that means reject the null hypothesis, which is the same decision. Here's the last question. Could somebody read the question? You don't have to write the numbers. You don't have to read the numbers. Go ahead.
Consider a population of frogs living on an island. We believe that frogs may be members of a species called Rana pipens. The mean length of Rana pipens is known to be 11 centimeters. The following length values, centimeters, were obtained for a sample of individuals from the island. Do these frogs have sizes that are consistent with them being Rana pipens or not? Are these frogs Rana pipens or not? Use a 0.5 significance level. No, 0.05 significance level.
Perfect. So first of all, we want to write the given. When we count 1, 2, 3, 4, 5, all the way to the end, we know that we have n equals 20, alpha is 0.05, and for this type of frog, this species of frog, Rana pipiens, it is supposed to have a mean length. In this case, mu equals 11 centimeters. So those are given. So if we could come up with the mean of the same, that means it's the same species. If it's different, that means it's not. Number one, the data, we have to put it into technology. You don't have to do it by hand. We are interested in calculating the X bar and S. And if we put it into a calculator, it does it for us. Since we are checking the average, the mean, so we are interested in this part. So we are going to go with H0 mu equals 11, and H1 mu is not 11. So pay attention to the way we write it. H0 mu is 11, H1 mu is not 11. So right away, the reason you say it's not 11, because if it's other than 11, then it's not the species you want. If it is, yes, it is. So we're going to call this the claim, meaning if we end up here, then yes, they are RANA ppms, those frogs. If not, whether it's less than or greater than 11, it won't work, and it makes it a two-tailed test. Sigma is missing. Therefore, we use the T. X bar minus mu over S over square root of n. Why are we using this? Sigma, population standard deviation, is missing. So we have negative 2.3491. Choice of alpha, normally, this is in, science, in biology. Alpha is normally 0.05. In this case, degrees of freedom is n minus 1 or 19. And if you go with the table, you can see the T is plus minus 2.093. And why is it plus minus? The area in two tails is alpha of 0.05. I'm assuming everybody can look up the T table by now. Let's do the drawing. So this is 0.05 divided by 2. This is 0.05 divided by 2, or 0.0025. That's the idea. And in between is 95%, okay? So 0.05 is the area of both tails put together. Now let's write the location for the critical value. Negative 2.093 and positive 2.093. Compared to that, this number is somewhere in between or somewhere in the tails. This number is less than negative 2.093. The test statistic is in the left tail test. This number is less than negative 2.093, puts it in the left tail test. Therefore, you are going to reject the null hypothesis. So if you're rejecting the null hypothesis, you're rejecting the claim. And we can't say that they are the same species of frogs. Reject the null hypothesis. The claim becomes false as a result. The claim is false. There is not sufficient evidence to support the claim that these frogs have sizes that are consistent with them being RANA ppms. The conclusion, therefore, is these are not RANA ppms. These are not the same species of frog that we were thinking. And of course, if you use technology, for example, in this case, Excel is used. Take a look at what you have here. The critical value is minus 2.093 and plus 2.093. It has it here. Test statistic was calculated is here, minus 2.3491, and it has a lot more decimals. The p-value is here. Look at this p-value, 0.02979, and you compare it to the choice of alpha, which is 0.05. This number is less than alpha. You have the same decision, which is rejecting the null hypothesis. Rejecting the null hypothesis.